Hello guys, how are you? In this video we're gonna to take a general revision for the chapter. Section 1, the nucleus. As we said before, nuclei are made of protons and neutrons, and we're gonna to call them here nucleons. So instead of keep saying protons and neutrons, both of them will be called nucleons. And the atom itself is referred to as nuclide, because here we are talking about the atom without the electrons. So nuclide means the atom of the element itself, and the nucleons means protons and the neutrons. And we said that also the difference in the mass of the atom is less than the total sum of masses of protons and the neutrons and the electrons, and this is what we called mass defect. And the nuclear binding energy is the energy released when a nucleus is formed from nucleons. And this is why the real mass of the nuclide is less than the sum of masses of the components. We should also say that the binding energy per nucleons is used to compare the stability of the different nuclides, and the intermediate atomic masses have the greatest binding energies per nucleons and are therefore the most stable. And we said that the most stable nuclei are those with a neutrons protons ratio of approximately 1 to 1, and the atom will be stable even if the ratio increases to 1.5 to 1. We also talked about the band of stability, which is here we are talking about the same thing, ratio between neutrons and the protons. We said that if the atom located inside of this band, that means that we have a stable atom. And we said, for example, if we have an element X with 100 atomic mass and 40 atomic number, that means that the protons is 40 and the neutrons is 100 minus 40, which is 60. So ratio of a neutron over a proton equal 60 over 40. So it will be 1.5. So the ratio is 1 to 1.5. That means that we are in the stable band, so the atom will be stable. Another example, if we have an element with here the protons 50 and the neutrons will be 80. So the ratio is neutron over proton, which is 80 over 50. Here the ratio is 1 to 1.6 almost. So that means that here we have an unstable atom. Third example, for example, 20, 40. That means that protons 20 and the neutrons 20. So neutrons over proton equal 20 over 20. So the ratio is 1 to 1, which means a stable atom. And we should also, as we have electrons distributed around the nucleus in a certain orbitals, we have also nuclear shell model, which says that nucleons exist in different energy levels or shell inside the nucleus. And the numbers of nucleons that represent completed nuclear energy level is 2, 8, 20, 28, 50, 82, and 126, which called magic number, which means the first level contains only 2 nucleons, second level 8 nucleons, and so on. And we also discussed that the nuclear reaction affect the nucleus of the atom. So here we aren't talking about moving of electrons, but we are talking about a type of transmutation, which is change in identity of a nucleus as a result of the change in its number of its protons. And we said that the element will be changed totally to a new element, and this process happens by releasing or by formation of 4 types of radioactive nuclide emissions. First one was alpha particles, which is helium. Of course, here we are talking about helium without electrons. So we are talking only about 2 protons and 2 neutrons, and the charge of it will be +2. And beta particles, which is actually electrons, so the atomic number is -1. And the third one is positron, same particle like electron, but with an opposite charge of +1. And last, we have gamma rays, which is a type of electromagnetic wave with no mass and no charge. Now, if we're going to take some examples, for example here, polonium goes to transmutation by releasing alpha particles or helium, and polonium will be converted to lead with less atomic number. So releasing of alpha particles will decrease the atomic number. And releasing of beta particles will increase the atomic number. As we can see here, carbon 14 converted to nitrogen with releasing of electron or beta particles, because as we said, this electron will be released from a neutron. So the neutron will release a negative charge. So the rest of the neutron will be positively charged, which is actually, it will be proton. This is why the atomic number increases. And in positron emission, which is the positive charge, as we can see here, the atomic number will be decreases because the proton will release the positron, which means that imagine the proton which is positive, it will release the positive charge from it, and the proton will be changed to be neutron. This is why atomic number decreases. And we have also electron capture, which is an inner orbital electrons is captured by the nucleus of its own. So the electron will be captured and the proton will be neutralized with the electron, then will be converted to be neutron. So here also the atomic number will be decreases. Finally, gamma rays, as we said, it is a high energy electromagnetic wave, which very high ability of penetrating bodies, so it's considered to be the most harmful radiation. Another examples here, we have thorium with beta particle decay and releasing. Number 2, we have alpha decay and positron emission in number 3, and electron capture in number 4. As you can see here, sodium converted to neon by electron capture. We also discussed the half-life, and remember guys that here in this video we are just talking about the main points we discussed already in our chapter. And half-life could be calculated by using Nt equal n node times half to the power t over t half. This is the half life, and t here, the time, total time, and here the total amount, and here in node is the initial amount or quantity. So we can find out the initial quantity or the total amount or total quantity or the time needed to have specific quantity, or even we can find out the half-life of any material. And we see that half-life is the time needed of half initial quantity to decay or disappear, and it depends on the nature of the element. It could be fraction of seconds or thousands of years. And here we have the practice questions here. You can check it and you can see the answers to check your calculations. Most of the questions here already solved before. Then we discussed the decay of elements to many other elements, and we said that the first nuclide will be decay is called parent nuclide, and the parent nuclide will decay to form many daughter nuclides, as we see here. So here uranium is the parent nuclide, thorium, palladium, and uranium 234, and all of other nuclides considered as a daughter nuclide. And we said that we can make transmutation artificially. It is not only natural transmutation, and this happened by using particle accelerators and making bombardment of a nuclide with other particles like alpha or beta particles or neutrons. And we will have many other isotopes that could be formed. But we said that this transmutation must be controlled first. And also we said that artificial transmutation is used to produce transuranium elements. And we said that transuranium elements are elements with more than 92 protons in their nuclei, which are located after uranium. Here you have the section formative assessment with the solution. You can just watch it. We said also that nuclear radiation could be measured or detected by using film badges or Geiger-Miller counters or scintillation counters. three methods to detect the radiation. And the usage of radioactivity could be used in radioactive dating, which is determine the approximate age of an object, or could be used in medicine by using radioactive tracers, or even in agriculture by using radioactive elements to study the fertilizer's effect on plants. We should also nuclear waste is unusable in the materials that contains radioisotopes, and we discussed how we can preserve the nuclear waste and protect the nature and living organisms. In our last section, the previous video, we discussed the nuclear fission and the nuclear fusion, and we said that we have a chain reaction, which is a reaction that materials starts. The reaction is also one of the products, and a lot of other nuclides will be formed in a chain and a continuous reaction. And we said that the chain reaction must be controlled by determining the number of neutrons released or controlling the speed of neutrons, because the neutrons bombard another nuclide. So if we control the speed of neutrons, it will not be fast enough, or it will not contain enough force to bombard another atom. Or if we decrease the number of neutrons, we will also control the number of nuclides that will be bombarded, and so we will control the reaction itself. And in nuclear power plants, finally, we said that we have the shielding, which is a material that absorb radiation to decrease it, especially gamma rays. And we have also control rod, which are neutron absorbing rods, will absorb the neutron to control the number of neutrons released, or moderator, which used to slow down the fast neutrons and control the reaction itself. We see here in this shape how we can produce electricity by using nuclear reactions and the nuclear reactor, and the moderator here, as we said before, used to decrease the number of neutrons. And we have the coolant, which is liquid water that will carry the energy to cold water and boil the water to change it to vapor, then use this vapor or steam in turbines to generate electricity, and so on in a circular motion. Now, let's just solve some questions here. Balance the following nuclear equations. As you can see, potassium converted to calcium. As you can see here, the atomic number is increases. That means that a neutrons changed to protons. The atomic mass is the same, which is 43. So the particle here in the first equation, will it be alpha particle or beta particle? What do you think? Of course, it will be a beta particle or an electron released. You can solve the rest of the question, and here I will show you the solution. Question number 11. And 12 and 13. this solution. The first one is beta particle, then electron, then helium, then carbon. Of course, you can pause this video and check the answers, the whole questions here. Thank you and see you in our next video.